Hey guys, today for my ALPS number 1 project, I'm going to be completing a couple of problems that I came up with and teaching you how to do them. So the first problem that I came up with here is a word problem I wrote. It goes, there's a large fire at a local Raleigh home. Local firefighters use an 18-foot ladder to lean against a building with a bedroom window 9 feet off the ground. What is the ladder's angle of elevation? The first thing we can think about when completing this problem is any information that we can just get rid of that's considered not important. The first thing that we can get rid of here is the beginning, that there's a large fire at a local Raleigh home. It doesn't really give us any information about the problem, so we can go ahead and get rid of that. The next thing we can think of is any important information. So we're seeing that there's a firefighter using an 18-foot ladder leaning up against a building, so we know that it deals with a 90-degree angle at the bottom because that there's a building, and that the window that it's leaned up against is 9 foot off the ground. So we can draw a picture of this. The first thing we'll draw is the building right here, and then we'll have the window, say, right here. This will be the window, that little square. Not the best drawing, but it gets to the point. And we'll know that this is roughly 9 feet. Then we'll have an 18-foot ladder leaning against this window, so it'll be roughly twice as long. So that'll be roughly about like that. The picture is not completely to scale, but it'll get the job. So this is going to be your ladder, just your picture of your diagram. And we'll know that that is roughly 18 feet long. Then we'll have this as just an unknown length, being A, C, B. Then we'll have our 90-degree angle, which was created here, which is the big C. And we'll know that that is 90 degrees for future reference. And then, again, what we're looking for here is the ladder's angle of elevation. That's the main question that we're being asked. So that would be right here. Created there. And then we'll have this angle. We'll call this angle, this is big B, but we'll call it X for now because that's how we'll solve the problem here. We can figure out using SOHCAHTOA, mind the handwriting, that we have an opposite right here and a hypotenuse right here for this angle right there. So that means that we use sine, SOHCAHTOA. So what it'll be is it'll be the opposite over the hypotenuse, which ends up being, to find this angle, angle X, sine X is equal to 9 over 18. Then what we'll do is we need to figure out how to get what X is equal to. And the way we'll do that is we will turn this into sine inverse. It'll become X equals sine inverse of 1/2. So then the next step in solving this equation is we'll have to pull out our unit circle. Our unit circle right here, we'll know that it is sine of 1/2. So we'll have to use either this 1/2, which is equal to 150 degrees, or this 1/2, which is equal to 30 degrees. We can go ahead and rule out this one because it's 150 degrees, and we know this angle could not equal 150 degrees because 150 plus 90 is equal to more than 180. So that only leaves this angle left, being that angle X is equal to 30 degrees. Now that we have these two angles, you can add these together and you'll get 90 degrees plus 30 degrees is equal to 120 degrees. subtract that by 180 degrees, because that's the total number of degrees found in a triangle. And you'll get your angle A, also known as the angle of elevation, of 60 degrees. So you'll find that your angle of elevation will be 60 degrees, and that is your answer to this problem. Hey guys, for the next problem I'll be teaching, it'll be a graph of f of x is equal to 3/4 cosine x. So the things we'll be looking for here are the amplitude, the period, the phase shift, and the vertical shift. And being this graph is kind of small, that of a printout, it might be kind of hard to see on the camera, I attempted to, as neatly as possible, write just a quick thing of where these points are plotted. So we have x of 0, f of x equals to 3/4, and so on, as can be seen in this right here. So the first thing we'll be looking for here is the amplitude. Now, the amplitude is just how high does the graph go above the midline. So the midline we can see is at 0, or we can just look down here. We can see that the top here will be at 3/4, and the bottom will be at -3/4. And the midline is roughly at 0, so we will obviously know that the amplitude is 3/4. Another way is if you have the equation available, it is just A, which would be considered A here. It's the absolute value of this at the beginning of your problem. The next thing we're looking for is the period. Now the period is how long does it take to repeat? And here we can see when it's up at the top, right here in the beginning, how long between here and here until it's back up at the top, repeating. So you can either just, since this is starting at 0, we can see by the time it takes 2 pi to repeat. So that will give us our answer of 2 pi for period. Now the next two will be our phase shift and our vertical shift. We'll start with the phase shift. The phase shift is how much does the graph move left or right. We can see that it starts at 0, and also we can see that there is no inside left or right movement of cosine of x. So we can already see that the answer to the phase shift is 0. Now for the vertical shift, it's how much. It would either be, in the problem you could see plus d, there's nothing on the outside here, meaning up or down of the graph movement. But when looking at the graph, you can see that the midline 0 here, the midline would be either moved up or down based on the equation on what's given. And we can see if the midline 0, the vertical shift will also be 0. And that is how you solve this problem.